This video is going to be how to connect slope lines with differing elevations and a change of direction. Um, First, I want to show you what I found here on tolerances for Caesar 2 pipe stress analysis. This is what they recommend, and I've been using 5/1000ths of a millimeter. Now, this is Caesar 2, the only pipe stress analysis program I'm familiar with. But I'm assuming that other stress analysis programs have a minimum tolerance requirement for their continuity also. Um, Probably be a good idea to check and see what they are and set up your CADWorx accordingly. It's easier to do it right the first time than it is to go back and change a bunch of fittings to get them to work in the stress analysis software. Anyway, there's a lot going on with this model because of the different angles. We've got the slope, then we've got the angle of the connection. This is 45 and this is 30. And then as this 90-degree rotates about the longitudinal axis of this line, this angle changes in the plan view. That angle starts to change. You can see it's slightly off tilted in that view. It becomes very difficult rotating those angles or those fittings to get them to line up. So what I came up with was setting up a pattern to use, and this is the pattern that I set up for a 45-degree volt 90. And if we look at the center lines of these pipes, we see that it's 180 degrees on the compass. It's 5729 from the XY plane, that's the slope, and this one gets 270, which means got what, 90 degrees between these two lines, and there again is our slope. And if we look at the angle here, here we see we've got 90 degrees. Now when we use the same if we do a slope, look at the angle from this center line to this center line, we get the not coplanar. Way to get around that, I found, as I drew a line down the center line and then just copied it over to that point of the center line. Now when we look at it, we get the 135, and that's equivalent to a 5-degree angle. So anyway, that being said, let's make one for this 30-degree roll. Start off with just straight pipe, no angle on it. And I got this set for 15, there's 30. Tighten this up a little bit. We'll isolate this. First thing we'll do is rotate that to a 1% slope. We got to get on the XY plane here. Left is looking east. Rotate all of that. Right. 5729, enter. 1% slope on that. Let's get around. Rotation. Pipe. And that helps. Got XY. This one is minus. Right, we got our slopes. $90. This has to be 90 degrees. This is a 90-degree socket, so the pipes have to be 90 degrees, right? Not coplanar. So the way to get around that, just copy this center line pipe or marker over to that endpoint. I'll do measure again. And 30 onto that is 180. Good. Let's list. Look at how these pipes lie. 0. You add 5729 on that and you'll get 360 for the slope. It's this one. 270. There's the slope. So we know we got 90 degrees between those two. So we've got our template set up. 30 degrees. Now, if your model isn't aligned to AutoCAD's true north, in other words, the world coordinate system, a lot of those preset coordinate systems, CADWorx, don't function properly all the time. But not only that, it just makes it more difficult to work in the model when it's not aligned to the world coordinate system. That's also true in Revit and in Navisworks. And in Navisworks, what it does is your dimension function in Navisworks for the XY dimensions is useless. The only thing that works is the height or the z-axis. So rotate your model so it's aligned to the world coordinate system. You can always rotate it back to a site north if that's what your client wants to see at the end of the project. Now you'll notice when it asked for the one to stay in the keeping location, I use this end pipe. Now, not only do you have to change the size of the pipe, you got to make sure you change this to the spec for this pipe and the line number before you make the connection. Now, I'm going to move this. I'm going to use the corner point. There. Drag this down. Should have checked the continuity to make sure that was good there. Okay. And 90 degrees, just what we want to see. And now we'll copy the other half of this down. We want that like the pipe. So change size. Again, you want to use a straight run for entity or a component to keep position. Delete it. Lengthen this up a little. This one we'll just move at the end point. Right. Let's get it. Well, I normally draw a little short line there so I don't have to go all the way down here for the other end. Just that. Now let's see how it turned out. Well, I could probably just move that over, and with those small variations, it is well within the limit, tolerance limit. But for exercise purposes, let's go back. That puppy over. This time I all right. Now you can see the amount of effort that goes into setting this up properly. Want to get in the habit of using Control S. Save your work frequently, especially when you're working with a large file and doing complicated, time-consuming editing sessions. Now there's all kinds of ideas on how to save your work. I already did this once before. Anyway, check our bottom pipes. Same. 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 We're all good. As I was saying, Control Save is the only sure way to keep from losing a bunch of your time. Exiting out of the program and starting it up is no guarantee that it's going to save your work. The program could crash 15 minutes before you decide to get out and start it up again, and you wind up losing an hour, hour and a half worth of work. Actually, exiting out of the program and starting it up again is a waste of time. Just use Control Save. When the program crashes on you, got your work saved in your original drawing file. If you can't get to that, you've got a backup file. You can also set up autosave. However, autosave does cause some performance degradation. I suggest that you go to Autodesk, Google back up and auto save and take a look in Autodesk Knowledge Base to learn more about it. Thank you.